Hey folks, welcome to another episode of AKS Me Anything. Today I'm here with Mitch, who works in our Istio and Service Mesh teams. Thank you for joining us, Mitch. What's some of the things that you folks have been doing? I mean, we had, I think, Fuyan joined us a while back and talked a little bit about some of the things that we're doing in the traffic team more globally in regards to kind of ingresses and the gateway API and some things a bit more. What are some of the things that you've been doing in the team?
Well, we've been hard at work bringing a sort of managed mesh offering to the market, and that's going to be coming a little bit later this year. So I'm really excited about seeing that. And that's involved both upstream work, getting all of our dependencies met in the upstream Istio project and integration with a few other projects, as well as behind the scenes work here at AKS. And really it's about like reimagining the baseline for what you get from a Kubernetes network. Usually when we think of Kubernetes networking, you get a few features by default, and then you sort of need a shopping list.
Right.
You need a CNI to get you some network policy. Maybe you need a service mesh depending on your encryption needs. You're going to need an ingress. You might need some traffic shifting and that. Rather than having that be a sort of shopping list that you have to pick each item and make different purchasing decisions, what if as soon as you turned on your cluster, with one click, you have all of those technologies available in cluster with same defaults ready to go?
So instead of being like, I usually use a different analogy, but very similar to what you're trying to convey, which is kind of the Lego box analogy, right?
Yes.
Just having to assemble the Lego yourself and having to kind of really go pick the pieces and find them out, and then stepping on the Legos sometimes as well and struggling through it.
Our customers who love Legos can still do that.
Great.
We're not talking about taking that away from them, but we're finding that a lot of customers really want an opinionated solution that works out of the box.
Right.
And with the way that technology has developed, there's no reason we can't provide those like really high security guarantees, traffic encryption, policy, right from day one, rather than waiting for customers to figure it out for themselves.
So I was going to ask that exactly. So what are some of those things that you've heard from customers that are just so important that they really want to have just out of the box? They're just so common out there. What are some of the key scenarios for the audience that maybe is like, all right, cool, I like things out of the box, but what should I be actually looking for?
Yeah, the number one thing that drives customers to service mesh is encryption. Sometimes they've got no encryption in their cluster at all. Other times they'll have more perimeter-based encryption, like WireGuard. And
what does that mean? Perimeter-based encryption.
Well, so you're always talking about your perimeter encryption, and that's how many things share the secret that's required to create the key, and what guarantees does that secret give you?
Right.
So if you think back of the old data center days, you could have a VLAN across multiple data centers using VPN, and the perimeter is every computer that's in that VPN is 100% trusted. There's no way to distinguish one computer from another. IP address is not a safe, thing to use for security.
So everything inside that perimeter of that boundary, you kind of trust it implicitly.
Yeah, there's two values. There's outside and there's inside. And if you're inside, you're trusted.
Right.
What mutual TLS does is it says, okay, let's forget these large perimeters, because I've never drawn a perimeter around more than one computer that didn't eventually get infiltrated by a bad actor.
Right.
Instead, let's say every connection on the network guarantees cryptographically the source and the destination the same way that we do when we access our banking app.
Right.
But rather than it being between a human being and a banking service, it's now between two pods. Maybe on the same network, maybe on different networks, maybe in different regions around the world, but they have full cryptographic guarantees of where the traffic is originating and where it's terminating, so that if there's a compromise, if one of those two is compromised, all it can do is compromise that one connection.
Right.
It can't move laterally in the network.
Right. So even if it's kind of one of the key principles of zero trust, right? Even if that one is compromised, you can't move laterally and cause a lot more damage to it.
So we've really asked, like, why isn't that just default?
Right.
Who needs to have a network where they explicitly don't guarantee lateral movement being locked down? Now, there's probably some.
And what are the trade-offs, right? Like, if that is not default, usually the concerns with defaults, right, as everybody is possibly painfully aware as something changes under their nose, right, and outside their control, is, okay, cool, you're doing something now that is a default, or that is just like always a case, always on, always off, whatever. What am I losing? I'm gaining a lot. What am I losing?
So there's always kind of two dimensions to trade-offs with service mesh, which of course is this sort of technology that you use to solve this problem. The first one that we spend a lot of time talking about, but I think may not be as important as it sounds, or just getting to be as important as it sounds, is compute. Encryption is never free.
Right.
It's more complicated to send encrypted traffic over a network than it is to send unencrypted traffic over a network. And so there's always going to be a cost in terms of CPU, memory, latency. But over time, those approach zero. We're shaving those down to where they're relatively minor overhead. Most of our customers are not going to notice the computational overhead of workloads that are using MTLS.
Most high-performance systems today, distributed, etc., they are encrypted and they are high-performant.
Right. Again, probably using like those more wider perimeter-based encryptions.
Right.
It's not harder computationally to do a mutual TLS channel than it is to have a larger perimeter. So why not have the smaller perimeter?
And so for a user that maybe is, all right, I want that, and I know that a lot of those maybe more advanced systems that I maybe use every day, they are using encryption, they are using these technologies, and I understand that they're better. Maybe I'm willing to pay that additional and even fractional, or even you can disregard that cost maybe computationally. I mean, the fraction of a CPU that it takes to encrypt and decrypt. But then, is there any operational cost to me?
That's the second dimension, right? And that's where users tend to get hung up. Because while CPUs are getting cheaper every day, devs are not. And so maintaining a service mesh is very, very difficult. We did a study a few years back in the Istio project, and at the time found that over 60% of users were not keeping their mesh up to date, even with critical CVE patches. So you've got this piece of software that you've put in your cluster for security purposes,
right,
and instead you've sort of centralized all your CVEs into one place so that everything can be compromised the same way. So Istio has now been focused for 4 years on reducing operational complexity in upstream. It's something we've been very aggressive about doing. And I think we've done a good job, but the great thing about working at a place like Azure is we can go a step further than what open source can provide. Rather than saying, we'll make upgrading easy for you, how about we make upgrades happen without you even being aware?
Right. Because you can offer it, again, as a service. It's not something you can install, and eventually there's only so much you can do from a project perspective. Eventually you're going to have to do it, to go that step further. It's where services and online services come in.
My success criteria is that users spend 0 time thinking about what version of a service mesh they're using and how it's going to get upgraded across regions or what infrastructure they need to spin up to support their service mesh. I want them to write an API that tells us what they want from their network, and then let us take care of doing that with their network right away.
I mean, I was doing a side project the other day, and I took it as a success criteria for myself that I created I was using an automatic cluster, and I was using the Istio add-on, the current add-on that we had. And to this day, I have no idea which Kubernetes version I used and which Istio version I was using, and all just worked. And I think that's a very good criteria to do.
It just works is absolutely the motto.
Right. Very, very good. Awesome. So that's all that work to kind of reduce that complexity and offer those capabilities that are, I think everyone at this point knows their value out of the box without those 2 dimensions of issues and complexity, of cost that we typically have. So that's a lot of work that you folks have been doing. What are you most excited about for the future?
Well, I think I'm really excited about the way that Istio and this new managed product are going to act as a platform for other technologies. So historically, you choose a service mesh or a network provider of some sort, and you're sort of placing a bet. This technology or that technology or the other technology. But Istio's new ambient mode is structured in such a way that you don't really have to place that bet. Sure, we'll give you a gateway API implementation called the Istio Waypoint or Istio Ingress classes that you can use, and it'll work the same way that Istio always has. It's great. But if you have a better gateway, we can put that there. We have some friends who have been working on some amazing tooling for running AI. And a lot of it is not quite made its way into Istio yet. It's still like an early alpha, and others are moving to maturity more quickly. We can take those tools and say, hey, run this in Istio Ambient, and they interoperate because those contracts are really well defined and very generic. So we're going to be able to provide the best-in-breed proxy, the best-in-breed gateway for running AI workloads, consuming AI workloads, securing model context protocol, etc., without necessarily having to have it all packaged into the Istio project.
Oh, that's very cool. And so it still gives that simplicity, but without having to really bolt in everything, make it very, very heavy.
Yeah. So we can still be opinionated and tell our customers which are the best gateways to run, which are the ones we're going to provide full support for. But at the end of the day, if they decide that ours aren't the best, they're welcome to bring their own and put it in. It's a well-documented process.
Cool. And still have the rest of the benefits.
Exactly.
Very, very cool. Awesome. And that supports us in kind of the AI revolution age that we're all living through right now, which is pretty exciting. Thank you very much for sitting down with me. And that was a very nice conversation. I hope folks appreciate it. As always, don't forget to like and subscribe and let us know which topics and which areas. This is one of the ones that you folks requested a lot. It's kind of a bit of a deep dive into what we're doing upstream with Istio. So I'm glad we could lift the veil a little bit into this, and we'll keep bringing all the topics that you folks comment and ask us to do. Keep liking and subscribing to the AKS community, and see you out there. Thanks, folks.